Okay, so let's do some practice. To what homologous series does C5H10 belong? Here's the easiest way I recommend doing it. Remember, N is the number of carbon atoms. So look at this, C5H10. What is N? N equals 5. If it is an alkene, right, I would just take the N and double it. So what is 5 doubled? 10. Is that how many hydrogens I have? Yes, and it's an alkene. If I had more than that, which would have been 12, it would be an alkane. If I had less than that, -2, it would have been 8, it would have been an alkyne. But in this case, the answer, to what homologous series does C5H10 belong? My answer is alkenes. Because do you see how this says homologous series? So the answer is alkenes. That is the name of the homologous series. Which organic compound contains a triple bond between carbon atoms? Well, where do I have a triple bond? So if you aren't sure, look at the structural formulas. Oh, there. It's a triple bond when it's an alkyne. So they have to end with Y-N-E. Easy peasy. There we go. All right, so think about hexane. Okay. How many carbons? Well, it's hex, right? 6. Which homologous series? Ane, it's alkane. What is the molecular formula? C6H, what do? I double it, 12, and then I add 2, 14. What is the empirical formula? Well, I have to reduce it, which means I divide. 6 divided by 2 is 3, and 14 divided by 2 is 7. There's the empirical formula. Structural formula, draw. C, 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 C. Ooh, 6. Now I have to add the hydrogens. Remember, every carbon needs 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now, I can write the H's at the end of each one of these lines, but I don't have to. It's okay, just like this, okay? If you write one of the H's, though, you got to go around and write all the H's. So maybe not, okay? What about the condensed structural formula? So that means I go carbon by carbon and say what's attached to it. CH3, CH2, CH, 2, CH, 2, CH, 2, oh my goodness, now CH3. In shorthand, I could write this CH3, and then in parentheses, CH2, and how many of them? 4, and then CH3. So sometimes you'd see it like that, okay? What is the molecular formula for an alkene with 7 carbons? All right, so C7H, double it, 14, right? Alkene, you just double it, right? Ene, double bond, use this formula, you just double it. What's the empirical formula? CH2, because 7 divided by 7 is 1, and 14 divided by 7 is 2. All right, think about 1-pentene. All right, so we have, again, all these questions. How many carbons? 5. Which homologous series? Alkene. I just look at the ending, right? The molecular formula, C5H, double it, 10. That's it. Empirical formula, CH2. 5 divided by 5 is 1. 10 divided by 5 is 2. Structural formula. So pent, 1, 2, 3, 5. Now, this 1 tells me where to put the double bond. I put it on carbon number 1, right there. Now, technically, this carbon over here is also, right here, is also a carbon number 1. So I could have put it here, but I'm just going to put it on this end. So let me erase this. Okay. All right, now what's missing? The H's, right? You check every single carbon. How many bonds can it form? 4. Count how many it has now and add enough lines. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And that's it. I don't have to write the H's. Okay. Now the condensed structural formula. I go carbon by carbon, right? CH, 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 2CH, 2CH. Okay. All right, think about 2-pentene. So this is almost the same as we just did. So the first part is going to be exactly the same. 5. It's still alkenes, right? Molecular formula is still C5H. And empirical is still CH2. Structural formula is still going to start with pent. I'm going to start with my chain of 5, but this time, this 2 tells me the double bond belongs on carbon number 2. Carbon number 1, carbon number 2. Okay, so you put it right here. All right, let's just erase those 1s and 2s. Okay. All right, now we put the hydrogen. So every carbon needs to have 4 bonds. So we put the lines for the hydrogen. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, condensed structural formula, go carbon by carbon and say the carbon and then what else is attached to it. CH3, CH, CH, CH2, CH3. Okay. Name this compound. All right, so let's look for our carbon chain. All right, so I could count 1, 2, 3, 4, 5, 6. Okay, or I could count 1, 2, 3, 4, 5, 6. How is it different? Well, if I count in the green way that I was counting, the lowest number that the double bond is attached to would be this carbon, and that would be carbon number 4. If I count the blue way, right, the lowest number carbon that the bond is attached to would be 2. So I have to pick the lower number. Like that's just the rule, okay? So I pick 2. Since it's a double bond, I know I'm going to end with -ene. So whatever I have at the end is going to be -ene. I need one of these prefixes based on how many total carbons are in the chain. So how many are there? 6. So it is 2-hexene. All right, this one. I don't see any double bonds. I don't see any triple bonds. So count how many carbons? 3. What is the prefix for 3? Prop. How do I end it? A-N-E. All right, look at this one. How many carbons? 1, 2, 3, 4, 5. So that is going to be pent, right? What kind of bond do you see? A triple bond. So that's pentyne. But I'm not done. Where is that triple bond? So I can number this way. 1, 2, 3. So I have the carbon triple bond on carbon number 4, and then this is 5. Or I number this way. 1, and then that has the triple bond attached to it, right? That would be 2, 3, 4, 5. So definitely is 5 pentene. The lowest number is 1. So it's 1 pentene. If you named it 4 pentene, wrong answer. Always pick the lowest number. Okay, so this one, well, I got a branch, right? So find the longest chain, right? So it's going to be this one. I could also get it like going, nope, can't get it going that way, right? So that is just simply the longest chain, okay? So now what? Name that. 1, 2, 3, 4, 5. That is pent. Okay, that is pent. Do you see any double or triple carbon-carbon bonds? No. Pentane. So I named the chain, but then I have this thing. So I got to name this, right? How many carbons are on that chain? 1. So that's meth. When it's a chain, I add YL. Okay. But I need a number now. What carbon number is it on? 3. It's 3 if you count this way, and it's also 3 if you count this way. So that one didn't matter for the number. No matter what, it's 3-methyl pentane. All right, this one, you got to find the longest chain, right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, no matter which way I count, I get 5. So let's just make it easy and use the center one. So that's pent. Do you see any double bonds or triple bonds? Nope. So pentane. Now I have 2 chains. Okay. So how do I have 2 chains? I have this one and I have this one. This one here has how many carbons? 2. So that is ethyl. And this has 1 carbon. So that is methyl. So how am I going to number them? I want them on the lowest numbers possible, right? So if I start counting 1 this side, 2, 3, it would be a 3 here and a 4 here. Or if I counted 1 this way, it would be on 2 and 3. Well, those are lower. So this is going to be a 2-methyl and a 3-ethyl. Now, which one do I put first? Literally alphabetical order. So I have to name this 3-ethyl. 2-methyl pentane. Phew, that's a lot. All right, naming this one. So you find the longest chain, right? So if I go straight across, I have 1, 2, 3, 6. Can I get a higher number any other way? Nope. So there's my chain. 6 is hex. Do I see any double or triple bonds? No, I don't. So what I have to check is make sure every carbon is full of hydrogens. I have CH3s at the ends. Those are good signs. I have CH2s in the middle. The only exception is right here, but because it had another carbon stuck on it. So this is all good. So this is hexane. I have 2 things off the chain. They both have 1 carbon. So they're both a methyl. Okay, but I need a number. So I want the lowest number. So I would number this way. 1, 2, 3. So how you name this, because both of them are methyl, you go 2, 3, dimethyl. Hexane. Whew, that was a lot. Oh my goodness. All right, that was a lot of content, but hopefully that helped and you learned something new today.